Hey everybody! Today we are going to begin chapter 9 in our book, which has to do with extending perimeter, circumference, and area. So we are going to open to lesson 9-1, which you will find on page 589, 9-1. And the title of this lesson is Developing Formulas for Triangles and Quadrilaterals. All right, so let's get started at the top of the page. This is about a 4-page lesson, so it is long, unusually long for us, and I'm going to try to move as quickly as possible. A good bit of this will be review for you, but taken to a new level probably. All right, so I want you to have your book open because I can't get far enough away from the book with how I mount my phone to be able to see everything at one time, so kind of float back and forth between looking at your book and looking at what I'm doing. All right, so this picture, this is called a tangram. It's an ancient Chinese puzzle made from a square. So you can see that the pieces of the square have been cut up and used to make a design. And we have a postulate that's going to apply to that. It's postulate 9-1-1, the area addition postulate. Now this is kind of like our segment addition postulate and our angle addition postulates that we learned early in the year. It says the area of a region, in this case a square that we started with, is equal to the sum of the areas of the non-overlapping parts. So looking at this tangram, that simply means that all of these are the pieces of the square, that the imaginary square that we cut all of these from, and we used every part of the square. And so what this postulate says is that the area of that original square is the same as the area of each of these pieces added together. Or in this case, you can see this little square that I drew and broke into lots of pieces. The area of this square, which is 4 times 4, or 16 square units, is the same as the area of each of the smaller parts, the triangles and the, I think there's a little trapezoid right there, and squares, that all of these areas of each of these parts added up would also equal 16 square units. So that's a simple postulate, and we're going to move forward using that to apply to areas of other shapes. So this part you might need to read along in your book because I can't fit the whole thing in my screen. But it says, recall that a rectangle with a base B and a height h has an area of area equals base times height. Or you may have learned it as length times width. But the reason we're doing base times height now is because we'll use base times height with our other shapes. And base times height sometimes helps us remember that our base and height, or length and width, have to be perpendicular to one another. That word height refers to something that is perpendicular to the base. You can use the area addition postulate to see that a parallelogram has the same area as a rectangle with the same base and height. So let's look at that. Here is our parallelogram, and I want you to look at it without the light purple triangle on the side. So here we have a parallelogram with a height of h and a base b. If we were to take the triangle off of the left side of this parallelogram, so take this triangle and move it, just shift it and put it back down right here, then it would disappear off the left side, and now it's on the right side. So now we simply have a rectangle just like this one. So this illustration is showing you that this parallelogram, the original parallelogram without the light purple triangle, because that's just showing relocation. So this parallelogram on the left has the exact same area as this rectangle on the right because we can remake it into a rectangle. And that's building on that area addition postulate, that these parts, even when they're relocated, will have the same area in the end. All right, so now we're going to talk about specifically the area of a parallelogram. The area of a parallelogram, as we said earlier, is simply base times height, where the height is perpendicular to the base. So let's start the math part by doing a couple of problems with that. We want to solve in example 1a for the area of a parallelogram, and we are told, let's see, here's the parallelogram. We are told that we have a base of 6 and a slant of 5. Now let's look at that without the little triangle on the side. Let's think about this for a second. We have a slant that is not our height because it is not perpendicular to the base. So what we need to do is redraw this and picture this parallelogram as if we had taken this triangle off the left side, as we did in the parallelogram above, and shifted it over here to the right side of the parallelogram, creating this little triangle where we now have a perpendicular height to our base. And they've told us that this little section right here, when moved to right here, is 3 inches. So we can easily use the Pythagorean theorem, a squared plus b squared equals c squared. We can plug in 3 inches squared for this and 5 squared for the hypotenuse of the triangle to solve for the height. So 3 squared plus height squared equals 5 squared, and that's 9 plus h squared equals 25. We're going to get h alone. H squared equals 16. Take the square root of both sides, and h equals 4. Now remember, this is a long lesson, so I'm going to need to be moving quickly. If you get confused, pause, go back a little ways, and watch it again, okay? So our height that we just solved for is 4, and now we have all the pieces of the puzzle to find the area of this parallelogram, which is a base of 6. Now, you might be saying, why is it not a base of 9, 6 plus 3? But remember, this little triangle is not part of this parallelogram. It's just what it would look like if we removed this triangle right here and put it over there. So our parallelogram base is actually only 6. And our height that we did the math on is 4. So our base times our height is 24 inches squared. And that is the area of the parallelogram. Okay, let's flip the page. We are at the top of page 590, and this is going to get just a little bit more complicated now. This problem, example 1b, wants us to solve for height when we're given the base and the area. So this is the height of a rectangle, and I am going to move you over to my notebook and draw this. Let's see. We have, I don't know if this triangle should be oriented vertically or horizontally. I don't have enough pieces of the puzzle yet to know that, so we'll just have to guess. But it tells us that the base is 5 centimeters, and it tells us that the area equals 5x squared minus 5x. That's what the problem tells us right there. Okay, so how in the world are we going to find the height? Well, we know our formula. We know the formula of a rectangle equals area, or is area equals base times height. So now we start plugging in our pieces in the appropriate places. This is not height, this is area, so of course it has to go on the area side of the problem. 5x squared minus 5x equals our base, that can go in the base spot, times our height. And we want to solve for h. Okay, so we need to move 5 to the other side of the problem. So that would be, well, before I do that, there's one thing that I want you to see, and that is that this can be simplified. There's a 5 in both of these, and if we divide both by 5, we would have 5 outside. So we factored a 5 out of this, and we're left with 5 times x squared minus x. That's going to make the problem a little bit easier, and then we have 5h over here. Now, we need to get h alone. If we divide both sides of this problem by 5, we're simply going to eliminate the 5's, and we're going to have x squared minus x equals h. And that is as far as we can go in this problem. There's nothing else that we can solve here. Our h, or our height, equals, x squared minus x centimeters. And this would need to be in parentheses. And that's all we can do on that problem. That is our height. And that is our answer. Okay, so now let's look at 1C. This time they want us to solve for the perimeter. So this is going to be even more of a multi-step problem. Also of a rectangle. So while I leave the phone right there, I'm going to draw another rectangle in my notebook. And this time, okay, we're solving for perimeter. So I have perimeter with a question mark. And it tells us it's a rectangle. And it tells us the area of this rectangle is 12x feet squared. Okay, so we know that, actually that's all we know from the instructions, but this one came with a diagram, and sadly that means that I oriented mine horizontally when it would have been better to orient it vertically, but we're going to go with what we've got. So we've got 6 feet for our height. All right, so once again, we're solving for perimeter, but first we've got to find out what our base is because we can't do our perimeter without our base. So area equals base times height. Remember, we need our height right there. Okay, our area is 12x. Our base is 6, and we don't know our height. But to get h alone, we're going to divide both sides by 6, and we are going to have 2x equals our height. So our height equals 2x. Now we have the pieces of the puzzle to solve for perimeter. You know from the past that perimeter is the distance around a figure, so we're simply going to add up all the parts. Perimeter equals, we could say, base plus height plus height, because they're 2 heights and they're 2 bases. Or a better formula for that would be 2 bases plus 2 heights. So that's really the formula for perimeter. So now let's plug in what we have. Perimeter equals 2 bases. Remember, the base is 2x. So we're going to say 2 times the base, which is 2x, plus 2 times the height, which was 6. Just going back to show you. The base was 2x, the height was 6. Now we do the math on this. The perimeter is equal to 4x plus 12. And that is as far as we can go in that problem. So we are going to label it feet. Now this is not area. This is not feet times feet. It's just the distance around that we could measure with a tape measure. So it's simply feet. Okay, let's see. I think we have time to do one more of these. This is check it out number 1. And it says find the base of a parallelogram in which h equals 56 yards. So let's find, here is our parallelogram. Our height, sorry, I kind of adjusted the phone by accident. Height equals 56. Our area equals 28 yards squared, and this is yards. Okay, so there you go. Now we know that area equals base times height. Oh, don't forget, they're ultimately asking us for perimeter, but we can't solve that without finding our base. So area equals base times height, or 28 equals base times 56. Now, our base is going to equal 28 divided by 56, which is 1/2 or 0.5. So our base here equals 0.5. Now, to do our perimeter, of course, we're just going to find, oh, I'm sorry, we were not asked to find perimeter here. Y'all forgive me. We were only asked to find the base. So we're done. Base equals 0.5. All right, that's the end of this first video, and I'll start back with the second one next.